The ConcreteSection program has the ability to give you some information regarding capacity relative to factored load cases, unity check type information. Let's look at how that's presented. If we have both loads for dead, live, and other sources, if we look at the load case manager under load combinations, we see that we have several combinations defined based on the building code selected, and I also have a custom combination. Many design scenarios require you to look at these combinations and compare them to capacity of cross-section. In the ConcreteSection tool, if we look at the interaction diagram capacities available, we'll see that, for instance, moment X interaction, we will plot these factored values on the interaction diagram, and you can get an idea of how close you are to capacity values. You can see several lie inside the diagram, which means they're safe, and we have a couple that lie outside the diagram, which means they don't meet the capacity requirements. Similar things for moment Y. If we look at the bending only diagram, we see also we have two outside the diagram. And if we look at the interaction surface, we see we have points outside the interaction surface. The last thing to comment on is regarding reporting, we have the ability to look at moment unity checks. And in the moment unity checks table, we have a moment unity value here. And you see we have values, a couple that are greater than 1, which means we failed, and one that's extremely larger. These unity values can be shown or represented graphically. If we look at cutting a moment-only slice at the factored axial force for a particular factored load, we have this diagram, and if we measure a distance from the origin of the diagram to the capacity point, we can call that distance D1. And if we measure from the origin of the diagram to the surface where this line drawn intersects the surface, and we can call that distance D2, the unity value we're showing is the ratio of D1 to D2. And when D1 equals D2, the unity is 1.0 and we're right on the surface. When D1 is greater than D2, the value is greater than 1 and we're outside the surface. So that's a graphical representation of the moment unity value.